to learn about switch security configurations, and we are going to configure almost everything that we have learned on that previous chapter. And so for this switch security configuration, we are basically going to implement what is called port security. Like I said, this is used to mitigate against MAC address table attacks. All right. Then to mitigate against VLAN attacks, we will configure DTP and native VLAN. Then to mitigate against DHCP attacks, we'll configure DHCP snooping to mitigate against DHCP starvation and DHCP spoofing. Then we'll configure ARP infection, DAIP, dynamic ARP inspection, to mitigate against ARP attacks. And to mitigate against STP attacks, that is spanning tree protocol attacks, we are going to configure PortFast and BPDU Guard, the Bridge Protocol Data Unit Guard, to mitigate against these STP attacks. And so to start us off, we are going to talk about port security a bit. And so let me give you a small background about port security. And so port security is, as a protocol which is going to allow us to secure our ports. What am I talking about? Securing ports. So what happens is this. Let's say, let me just bring up one of my packet tracers here for switch ports here to what is my port security packet tracer here? Yeah, so let me just look at this here. Exactly, yeah. So let's say that we do have trying to look for a diagram here, correct? Let's say that we have this diagram here, and we have our legitimate PC is right here, and we have this switch here connecting PC to port number 1, all right? And then we have two hackers, two illegitimate guys here who are trying to illegally access our network through our switch, because they have realized that some 2 ports are actually opened, fast Ethernet 0/2 and 0/3, all right? And we decide that since we have attended a port security class with Cisco, we can now be able to protect our ports here. And so this is what we are going to do. We are going to enable port security to allow this port here to be connected to this PC here. But we are going to shut down these 2 ports, port 2 and port 3. And we are going to make sure that even if this guy here on this laptop tries to remove the Ethernet cable from our PC and puts it on his laptop is not going to connect to the internet or to this switch. But if we return that cable back to our PC, then our PC works well. And even if the second guy removes our cable from our PC and connects it to his laptop, because this port is not working, he's not going to manage to connect with this cable. But when he returns the cable back to our PC is working just well. And this is what we actually call port security. We protect the port from being used by unauthorized users. And that is a very common practice that we need to learn with port security, all right? And this is just something very important for us to be learning. Now, let me go back to my browser here. I mean, my slides before we go back to do the configurations. And so since ports attacks happen at layer 2, some of the easiest of these attacks that hackers normally take advantage of could be mitigated using this protection at the port. And sometimes most network administrators just prefer to shut down the ports. That could work for you. But remember, sometimes, like in a school or a lab situation, you want to leave some ports either for people who might want to use those ports, okay? Or they might want to change from one port to the other, or the ports have been enabled for different VLANs. And so the shutdown port might not be the best solution sometimes. And sometimes you must just need to reactivate that port and using the command no shutdown. But you need to protect those ports other than just shutting them down. You can actually do something better than that. And so port security is one of those that you can use. One is to limit the number of MAC addresses that can be learned on that particular port. And you can either manually configure a specific MAC address to be learned on that port, or you can allow the switch to automatically learn a specific number of MAC addresses, okay? So that when a port configured with port security receives a frame, that MAC address of that frame is going to be compared with the list of any secure MAC addresses that it was allowed to learn. And so by limiting these MAC addresses to that port, let's say, for example, only one MAC address, the port can only be used to learn one MAC address at a time. And if the second MAC address tries to connect to that port, it's actually denied. And so the first thing you need to do is to enable port security. And the command for enabling port security is as simple. Before you do anything else, before you enable what, please remember, you must put this command to activate or to enable port security. Why am I stressing on this? I'm stressing on this because all the commands from here will always begin with switch port -security, all commands. But the first command you must put alone is the command switch port security. And port security, by the way, is normally only configured on ports connecting the switch to end devices. Port security normally is configured on access ports connecting switch to end devices like computers, laptops, so on and so forth. And that means the port must always be enabled with switch port mode access before you can enable port security. And looking at this diagram here, this guy tried to get into interface first Ethernet 0/1, then enable port security before putting switch port access, and they were told the command was rejected. And they had to configure switch port mode access before the switch could accept this command, switch port -security, all right? And it doesn't mean that securing the trunk port cannot be done, but this is just beyond the scope of this course as we speak. Now, so like I mentioned, you can configure the switch ports to learn MAC addresses, either manually by, of course, manually putting that MAC address, assigning a particular MAC address to that port, or you could allow it to just automatically learn the MAC addresses just after you enable port security. The only problem with that is that when the switch is rebooted, all the MAC addresses will be lost. Now, if you want the switch to automatically learn the MAC address but store them, then you need a dynamic learned sticky. You need to configure that port with the command switch port security MAC address sticky. I didn't mention to you to manually assign a MAC address to a port. You say switch port -security MAC address, then you copy the MAC address of your PC and you put it here. To enable it to automatically learn MAC addresses and return them on the NVRAM, you say switch port -security MAC address sticky. You don't need to indicate the particular MAC address here. And so let me just tell you how to basically do that here. Looking at this particular diagram, you can see we have enabled switch port mode access here. Then we enable port security. And like I was saying, from after enabling port security, all the commands now begin with the same command, switch port security. So if I want this port FA0/1 to be used by only the first 4 PCs, I only want the first 4 computers to use that cable connected to this port, I will say switch port security maximum. Then I can put 4, I can put 3, I can put 2, I can put 1. But for this case, we're using 4, which means if the first user comes with his laptop, connects to that cable, connected to that port on the switch, and then goes away, the second laptop comes, connect to that port, that is the second MAC address land on that port. The third Mac PC or the third laptop comes, connect to that port. The fourth laptop is connected to the same cable again. That port lands only the 4 MAC addresses it has been told to land. If any fifth PC or laptop comes and the user tries to connect that cable to that port, it will not accept. It will not connect to the internet. It will be rejected because that port has been configured with port security to only allow the first 4 MAC address of 4 devices that are going to use that device. If any of them come back, they will still be able to use that cable connected to that port, but no any other fifth MAC addresses will be learned. To manually assign a particular MAC address, you will say switch port security MAC-address, and you will put the manual MAC address. Copy the MAC address of your PC. You know how to check the MAC address. You go to the command prompt and you say ipconfig /all, and you'll be able to see the MAC address of your PC. To enable the dynamic or automatic learning of MAC addresses and adding them to the NVRAM, you say switch port security MAC-address. All right, so these are very important commands here. We are going to practice them in a few, and I will also give you avenues to practice more. If you want to view all those things you have configured, you just need to use the command at the privilege exec mode, show port security interface fast Ethernet 0/1 or FA 0/1. Show port security interface FA 0/1. You can see port security enabled, correct. Port status is secured up. We will talk about these three things here. There's a violation mode here is shut down. Aging time is 0 minutes. Aging type is absolute. Those are the default. These are default, and we're going to talk about them in a minute. Otherwise, look at maximum MAC addresses we had configured for, and you see the 4 is here. Total MAC addresses is 1 because the configured one was actually 1. Sticky MAC addresses that have been done automatically is 0 currently. The last source MAC address is 000, not existing. We could still say commands like show port security address if you want to see which MAC addresses that were manually configured for that port. You can see the manual MAC address we had configured on fast Ethernet 0/1. Show port security address, and that is actually here. Now, apart from that command, let me talk about aging, port security aging. Now, let's say you have enabled port security and the ports have learned some particular MAC addresses. Now, port security aging can be used to set the aging time for either it's dynamic or dynamically learned MAC address or manually or statically signed MAC address, such that if you talk about the aging type and we have the absolute aging time and the other aging time. I'm in class. Can I call you later, please? Hi, I'm in class. Okay, bye. All right. So the absolute aging time and inactivity aging time here. So the absolute aging time, the address on this port will be deleted. You know, we're talking about the aging again. It's, you know, I mean, for how long that is going to be there. So the secure address of this port will be deleted after a specific aging time. All right. After a specific time, the MAC address is actually going to be deleted. Then for the aging, for inactivity, this is whereby the address on this port is going to be deleted if they remain inactive for a specified period of time. If they remain inactive, that means the MAC address was learned, but either no browsing is taking place on that particular port, or there's absolutely no device connected. So it's going to be deleted. Okay. So if it remains inactive, the absolute is if it's going to be deleted after a specific aging time is actually configured. And so configurations could be done here for aging. You could say switch port security aging, switch port security aging, to be able to enable or disable static aging. And we can actually see an example here. Here we get to interface F01 and we say switch port security. You can see the command, all commands are starting with switch port security. Then aging time here is 10 minutes, but the aging type here, switch port security aging type is inactivity. Normally we saw that the default aging type is absolute, and the default aging time is always 0 minutes. So always 0 minutes. So you can see that inactivity is what we have configured here as the aging type, but aging time is gone to 10 minutes. Now, I want to talk about the last thing before I do some configurations is violation. Violation. What happens if someone violates that particular rule? Okay, you configure a port to only accept one MAC address at a time, but someone brings his laptop or the desktop computer and tries to connect to the same port, which is secured with port security, and the port tries to learn the second MAC address when it was only allowed to learn one MAC address. Obviously, a violation will occur. Okay, the switch will identify it as a violation, and the port violation is actually going to occur, and the switch is going to do three things because we have three types of violations. The default violation type is shutdown. Then we have two more methods. We have restrict and we have protect. We have restrict and we have protect. Now, we are going to use three parameters in order to identify these three modes here. One is if you are on shutdown, obviously the port is going to go into an error disabled state. And that means that the LED of the port or the switch, the ports, the lights you see on the switch ports is gonna go off. And a message will pop up on the command line. I mean, if you are on the CMD, or I mean on the command line of the switch, you'll see some syslog messages being generated of error disablement. You'll see those error disabled syslog messages being generated. And if you are able to see, I don't know if you're able to see it here, this part here, security violation counter, wherever any violation occurs, this number will always increase. All right. And so shutdown will increase, the violation counter will be incremented. Okay. So we've heard of two things. One, syslog messages will be generated. Two, the port will go in error disabled state. Three, the LED port will turn off on the switch, and it will be like the port is off. Okay. And when error disabled state occurs on the port, you as the network administrator, you need two commands to bring up that port. When a port goes into error disabled state, and this is a question that will come to your exams, you need two commands to bring it up again. So the first one, you'll say shutdown on that port, and the second command will be no shutdown. So you are first shut down the port, then activate it back. That is how to remove the port from error disabled state. So that is the default violation is shutdown, and those are the activities that take place. Then the second violation mode is called restrict. In restrict, the LED port will not be turned off. No, that means the port will not be shut down. But what the port will be doing is that the port will be dropping packets from any unknown sources until you remove that particular MAC address there. The violation counter will still increment when restrict is enabled, and syslog messages will be generated. Very, very important. Violation counter will be incremented, and the syslog messages will be generated, but the port will not go off. That is very important to note. Then we have protect as the last violation mode. We are told this is the least secure of these modes. And here, the port still drop packets from unknown sources. But in this case, no syslog messages will be recorded. And I think no violation counter is also incremented. Okay? No violation counters, no syslog messages. And that's why you might never know what is wrong with your switch. This is why it is the least secure of all your violation modes. And that's why always you either leave it to the default or set it to the restrict mode. Set it to the restrict mode. And how do you configure violation? You just need to say, get to that interface, F0/1, then you say switch port security violation, switch port -security violation, and you can set it to restrict or protect or shut down. Of course, the default is shut down, but you'll see the violation mode is here, is restrict, okay? Now, I want to do some configurations on port security just to allow you guys to be able to see that. So let me jump into this one here, and let's do some configurations right here. All right, so I'm gonna increase my to zoom in my page here, and let me just do this here, and we're gonna work on this here. Yeah. So I'm told you are currently logged into S1. Configure fast Ethernet 0/5 for port security using the following requirements. All right. And so we'll use the interface FA0/5 to enter the interface configuration mode. Then we enable port access on that port. All right. We enable port security. Then we're gonna set the maximum number of addresses to 3. We set the port to statically configured with this MAC address here. Then you configure the port to dynamically learn additional MAC addresses and dynamically add them to the running configuration. That is the sticky part. And then you're going to return to the privilege exec mode. So first things first, let's select interface interface FA0/5. So that's what I'm going to do. So I say interface FA0/5 and tap. We need to put it to access mode. So you say switch port mode access and tap. Then we enable port security. Enable port security, say switch port -security enter. Then we need to set this port to learn a maximum of 3 MAC addresses. We say switch port -security maximum 3. Good. Correct. Then we are told to statically configure the MAC address. That one, we say switch port -security, okay, MAC -address AAAA.BBBB.1234. Enter. Correct. Then we need to configure a port to dynamically learn additional MAC addresses and dynamically add them to the running configurations. You say switch port port -security MAC address sticky. Correct. Well done. Then we need to return now to the privilege exec mode and we say end. Correct. And now we are told to enter the command to verify port security for all interfaces. We say show port -security. Show port -security. And you can see that F05 is here. The maximum addresses is 3. Current addresses they are learned. Violation mode is not configured, so on and so forth. Then we are told to enter the command to verify port security on fast Ethernet 0/5, and we have been permitted to use FA0/5 for the interface name. So we say show port -security. No, we're supposed to say show interface FA0/5 switch port. Oh, what did I do again? Oh, I think we need to say show port security interface FA0/5. Yeah, this is what they wanted us to do. And so we could see the details of that particular interface. Port security enable, tick. Violation mode, default, shutdown. Violation aging type, default, 0 minutes. Aging time, default is absolute. Maximum allowed MAC addresses is 2. Total MAC addresses so far is 2. Configured MAC addresses, the manual ones, was 1. Sticky MAC address is 1 here. And the last source MAC address was this one from one of the devices. Security mode violation is currently at 0. Enter a command that will display all the addresses to verify that the manually configured and dynamically LAN MAC addresses are in the configuration. We say show port-security address. All right. And you could see that one MAC address here was manually configured on interface FS0/5. And there's one that has automatically, this MAC address has been automatically learned dynamically using sticky method to manually add it to the running configuration. And you can always save it to the NVRAM. Okay. And that is an interesting one. That is for port security. That is for port-security. Now, let me just reduce this back to normal here. Then we want to work on mitigating VLAN attacks. On mitigating VLAN attacks, as we had mentioned, remember the VLAN attacks we talked about, VLAN hopping and VLAN double tagging. And so for that matter, we are going to configure some commands here to protect us against these VLAN attacks. And so let's just see if I can be able to zoom this more. Yeah, this one here. So we are told you are currently logged into S1, and the port status of the ports are as follows. Fast Ethernet from 1 to 4 are used for trunking with other switches, all right? Fast Ethernet from 0.5 to 10 are unused, okay? And, okay. And then we are told that Fast Ethernet from 11 to 24 are actually active ports currently in use. And so the instructions are here. Using the range of Fast Ethernet 1 to 4, we need to enter the interface configuration mode for the trunks because they are being configured as trunks. So we say interface range FA 0/1 to 4. You need to be careful here. As you'll be, if you will be practicing this, it's not a must, but because this is called syntax checker, you're gonna put FA 0/1, put a space here, and then put hyphen, and then put another space, and then put 4. Otherwise, it will not accept. Configure interfaces as non-negotiating trunks assigned to default VLAN 99. So the first thing we do is that we need to say switch port mode trunk, correct? Then we need to say, since they are non-negotiating, we need to say switch port no negotiate. Non-nego. My spelling is wrong. Negotiate. Switch port no negotiate to non-negotiating trunk. So the first thing, you enable trunking, then you enable no negotiating such that the trunk will not be negotiating with another switch to form a trunk. Then we need to set it to remove it from native VLAN VLAN 1 to set it to VLAN 99. So we say switch port trunk native VLAN 99. Switch port trunk native VLAN 99, correct? Then we are now told, so we have disabled auto negotiation. It means this switch can never form a trunk with a hacker who has configured his PC to look like a switch. They can never form a trunk link. That is to prevent VLAN hopping attack. Then we need to get into interface range F0 5 to 10. So we say, sorry, interface range FA0/5 space hyphen space 10, enter. Then you need to configure and use ports as access ports. So first thing we say switch port mod access, correct? We need to assign them to VLAN 86, then we shut them down. So we say switch port access VLAN 86, enter, then we shut them down. You can see a notice there. If you had not created VLAN 86 and you want to use it, the switch will automatically create VLAN 86. That's very, very important. Then you say shut down. And that is very, very important again. Then we go to F011 to 24. Interface range FA0/11 to 24. We need to configure them to prevent trunking. Very interesting. Guys, to prevent trunking on a port, you need to enable those ports, set them as access ports. That is the command for preventing trunking. So you say switch port mod access. Very, very important command. To enable to disable prevent trunking, set your ports to accessport. So this is going to take care of VLAN hopping and VLAN double tagging. So the hacker can never be able to joke around with your device. So that was on VLAN attacks. Then let's proceed to attacks on DHCP. And on attacks for DHCP, we are going to configure what is called DHCP snooping. And just to explain a little bit here, in DHCP snooping, what you want to do is that you want to identify some ports as trusted and some as untrusted ports. All right. And so what happens is that all ports connecting to end devices, PC here for the hacker, all these devices within client devices, apart from the DHCP server itself, all the ports ending to user devices must be untrusted, because these are the ports that can be able to generate fake DHCP requests. So we don't trust those ports. And you can see the hacker's computer is connected here, which is one of those that we're going to configure to be untrusted. All right. So that they don't spoof themselves to be a DHCP server, or they don't send any fake request to the DHCP server to do a DHCP starving attack on our device. So what we do is that we identify trusted ports, and any port that is from the switches to other switches or to the DHCP server or to routers, all of those are going to be trusted ports. Once you do that, then you're going to enable what is called DHCP snooping, on your device. And so to do that, let's say F05 is untrusted and F01 is trusted. So what we are going to do is that you're going to first globally enable DHCP snooping. You say IP DHCP snooping. Then on the trusted ports, you say IP DHCP snooping trust. Then go to the untrusted ports and you say IP DHCP snooping limit rate 6. And what are you going to do? You are going to limit, these ports to only 6 packets per second. You're going to limit the number of DHCP packets, okay, to only 6 packets per every second. And you know what we are trying to do by limiting packets to 6 packets per second, you're limiting someone who is trying to do DHCP starvation attacks, DHCP starvation, so that they can never send more than 6 packets per second, to be able to exhaust all the IP addresses from your DHCP pool. Then you also do the snooping on all your VLANs. You say IP DHCP snooping, VLAN 5, 10, 50, all the way to 52, right? And that is very, very important. You can use commands like show IP DHCP snooping to be able to see all those details, or even to see which MAC addresses has been bound to which IP addresses. Show IP DHCP snooping binding, Now, let's see how, if we can be able to actually do something like that. You see this diagram here. We have the DHCP server is right here. We have the client PCs here. So F011 obviously is going to be untrusted, and we are going to trust G01 to G02. Those ones are going to be our trusted ports. So let's work on this to be able to protect our network against DHCP attacks. So you are told you are currently logged into S1. You need to enable DHCP snooping globally for the switch. You say IP DHCP snooping, IP DHCP snooping, correct? Then you're told to configure our trusted ports. You're told enter interface configuration mode for G01 to 2. Trust the interfaces and return to global config mode. You see, remember when there are 2 interfaces or more, use the interface range command for G0/1, 1 to 2. Then we need to trust them. You say IP DHCP snooping trust. DHCP snooping trust. Then we need to return the global config mode by the command exit. Then we need to enter the interface range for our untrusted ports, which is interface range F0/1 to 24. We need to limit the DHCP messages to not more than 10 per second. We say IP DHCP snooping limit rate 10. IP DHCP snooping limit rate 10. IP DHCP snooping limit rate 10 seconds. So only 10 packets per second, not more than that. Then we return to the global configuration mode by saying exit. And then we enable DHCP snooping for these VLANs. We say IP DHCP snooping VLAN 10, 20, don't put any spaces, 30, all the way to 49. Those are the number of VLANs we have here. To verify DHCP snooping, it will say show DHCP snooping. Oh, should be show IP DHCP snooping. I think so. Yeah, show IP DHCP snooping. You can see snooping has been enabled and is being configured for all these VLANs here. You can see here it's operational and it's configured for this layer 3 device here. And okay, the untrusted port not allowed, but we can see details about the trust. G01 and G02 are actually trusted, and F01 is not trusted, and the limit rate is actually 10 here for F01 for the untrusted ports. Okay, to be able to verify the current DHCP bindings logged by DHCP snooping, that means which bindings have actually been stored or logged or recorded by this device. We say show IP DHCP snooping binding. Show IP DHCP snooping binding. You can see that this first Ethernet 0/11/1, which is the untrusted port, it has bounded one MAC address here, all right, to prevent it from sending any fake addresses to the DHCP server. Its IP address of that PC is 10.0.0.10, and it has sent about, look at how many leases it has sent, which were blocked by actually snooping binding, about 193,185, okay? And the snooping is being done, that device is actually on VLAN 5. It's the DHCP snooping there. So this is very important to prevent attacks on the DHCP server, to prevent attacks on the DHCP server. Now, having seen how to mitigate attacks on DHCP, we can now be able to look at attacks launched on the ARP, the mitigating ARP or address resolution protocol on the ARP. And so, like I told you guys, what address resolution protocol does is that PCA, which is on VLAN 10, together with this hacker's laptop here, it needs to store the IP address, for example, and MAC address of the default gateway. All right. So it only knows the IP address of the default gateway since they are on the same network, but it does not know the MAC address. So what does it do? It sends an ARP request, and it needs to get the ARP request, which is requesting for the MAC address of the router interface. But the hacker is keenly listening here. And before the router responds, the hacker is going to respond with an ARP reply telling the PC that, you know what, I am your default gateway. I am R1 and my MAC address is here. So the PC is going to be fooled in storing the MAC address of the hacker on its ARP table together with the IP address. And so every time the PC wants to send something to the internet through the default gateway, it actually ends on the hacker's computer here. And so to protect us against some of these, we need to protect our ARP request messages and the ARP reply by configuring what is called dynamic ARP inspection. And in configuring dynamic ARP inspection, we combine it with DHCP snooping. And so the first thing we do is we enable DHCP snooping by saying IP DHCP snooping. Then we enable it on the VLANs, IP DHCP snooping, VLAN 10, and we configure ARP inspection by saying IP ARP inspection, VLAN 10. Then to configure the trusted ports, we say interface, for example, F024, IP DHCP snooping trust, IP ARP snooping inspection trust. Almost similar with the inspection. And you could as well be able to validate specific IP to MAC bindings. You can validate that the correct MAC addresses requested by the ARP request should be the correct MAC address returned through the ARP reply, so that we are not having a fake hacker's laptop responding a fake reply to the correct request from your PC. And so we could validate every source MAC address, source IP address and source MAC address. And by saying IP ARP inspection validate source MAC, that is source MAC address, IP ARP inspection validate destination MAC, IP ARP inspection validate IP. So you could actually configure this one using 3 different commands for the source MAC address, destination MAC addresses, and the IP address. Or you could still be able to put them on the same line by just saying IP ARP inspection, validate source MAC, destination MAC, IP. You know, the same thing basically that you are doing here. Now, so let's see how we can be able to protect against these ARP attacks, and we have this one. Remember, we still have our trusted and untrusted port, and G01 and 2 are actually trusted ports here. And apart from DHCP snooping, we are also going to protect them against ARP spoofing, ARP spoofing within our device. So let me just get to that here in a second. And we are told that we are currently logged into S1. Enable DHCP snooping globally for the switch. So we say IP DHCP snooping, right? Then you're told to enter the interface range G01 to 2. We need to trust the interfaces for both DHCP snooping and DAI, and then return to global configuration. Very simple. We say interface range G0/1 to 2. We say IP DHCP snooping trust, correct? IP ARP inspection trust, right? Then we go back to the global configuration mode. We just exit, and then we enable DHCP snooping and DI for VLANs 10, 20, 30 to 49. Say IP DHCP snooping VLAN 10, 20, 30, all the way to 49, correct? Then you say IP ARP inspection VLAN 10, 20, 30 to 49. And that's it. Very simple for enabling both DHCP snooping and ARP snooping. And the last thing that I want us to mitigate against now is our spanning tree attacks. We want to protect the network against spanning tree attacks, against spanning tree attacks, all right? So for spanning tree, which is STP, we are going to protect the spanning tree protocol from wrongly, like for example, this device here. Let's say that, the 3 switches, we have layer 3 switches and a layer 2 switch and our end devices here. Let's say one of them is a hacker's laptop and they manage to spoof, okay? They spoof, or they manage to disorganize so that the wrong switch is selected as the root bridge. And when that happens, what if some of these access ports are actually going to be alternate ports? All right, they become alternate ports. That means they get blocked, or at least one of them get blocked, while the others could be designated or, root ports. Now we want to prevent that from happening so that spanning tree works as it is expected to be. And so we have 2 things. One, we need these ports, as I have explained before. Most of our networks, of course, all our networks always use DHCP, okay? And remember what I said the other day, that from the moment your PC comes up, within the first 15 seconds, the first thing that the PC needs to do is to acquire an IP address from the most available DHCP server. If these switches were off and they come up, the first thing these switches need to do is to go through the switch ports need to go through the normal port states, which is blocking, listening, learning, and forwarding. We did learn during spanning tree that those stages take about 30 seconds for DHCP to converge within the switches. While within the first 15 seconds, DHCP needs to have provided IP information to these PCs, because the DHCP, after the first 15 seconds, the DHCP process begins to expire. All right. And so you don't want that to happen. And so what you want is that you need these ports to come up as soon as possible so that the PCs can acquire IP addresses within the first 15 seconds, and the network can be able to begin running. And so what happens is that you need to configure PortFast on the access ports connected to the PCs, so that the ports are going to reduce the time it takes or to shorten the time of the spanning tree process. And that means you want the switch ports to skip some of the ports to take a lesser time. And so the ports, instead of going through blocking, listening, learning, and forwarding, the ports are going to skip the middle two states for listening and learning, so that the moment the spanning tree comes up, the ports transition from blocking to forwarding immediately, from blocking to forwarding, and DHCP can now be able to do a good job. And we are going to see how to configure PortFast. And PortFast can be configured on the ports, or you can configure it on the global configuration mode that will affect all the ports. All right. Now, you know that spanning tree protocol, spanning tree, uses BPDU messages, the bridge protocol data unit messages, which are used to exchange during the election process of the root bridge, and even the election process of the specific port roles, like designated ports, or the root ports, or even the the alternate ports. And so what you want is that you want the BPDU messages to only be received on the specific ports connected to the switches, not the access ports. All right. And so to be able to secure these ports, you want to do what is called BPDU guard. You want to guard those ports from receiving the BPDU messages. And if they ever receive the BPDU messages, then those ports should go into an error disabled state, so that they are not going to participate in the election process of any role of the ports, because it might put one of the ports to an alternate port, and that is not going to be good news. You might find that a port connected to a PC has actually been put on alternate port, which means that port has been shut down, or it has gone to an error. I mean, it has been shut down or blocked, for that matter, to prevent spanning tree from we talked about the layer 2 loops. All right. And so I want us to check on how to configure those two things. So first things first, the port must be in Accessport. These are the ports that you configure at Accessport. It says spanning tree port first. If you put it on the interface, then it is only going to affect that interface. If you want it to configure it on all the interfaces, then configure it only on the global configuration mode, and you say spanning -tree port first default, spanning -tree port first default. All right. If you want to configure BPDU guard, you can configure BPDU guard either on an interface also, specific interface, or on all interfaces at the global configuration mode. So on an interface, you'll say spanning -tree BPDU guard enable. That is to configure it on a single interface. Now, to configure it on all the interfaces at the global, it says spanning -tree port first BPDU guard default. This is a very confusing one. Spanning tree port first, you must begin with the command port first, then you say BPDU guard default. And when you say show spanning tree summary, of course, you'll see, BPDU Guard is actually enabled right there. Let me see if we can do a brief configuration here. We do have some syntax checker here. Let me just zoom it so that we can be able to work on it. All right. So here we are told that we are currently logged into S1. Complete the following steps to implement PortFast and BPDU Guard on all Accessports. So we are told enter the interface mode for F1 to 24. So you say interface FA 0/1 to 24. What did I do? Oh, interface range, sorry. Interface range FA 0/1 to 24. Enter. Configure it as in access mode. You say switch port mode access. Enter. Then you need to configure ports for access mode. We've already done that. Then return to global configuration mode. We just exit. Then we need to enable PortFast default for all access port. We say switch port. Oh, we say spanning -tree PortFast by default for all access. We say spanning tree PortFast. Sorry, PortFast spanning tree PortFast default. Okay. Then we are supposed to enable BPDU Guard default for all access ports. You say spanning -tree. We say PortFast. Okay. Then you say BPDU Guard default. Very, very confusing commands. So you say spanning tree PortFast, BPDU Guard default. When you want to do it on all access ports, you do it globally. If we were supposed to, like we saw, to put it on one interface, we could just say spanning tree BPDU Guard enable. Yes. Then of course we are told to verify PortFast and BPDU Guard that is enabled by default by viewing this STP summary. Very simple. Show spanning -tree summary. Show spanning -tree summary, and you can see that the spanning tree mode being used here is PVST, per VLAN spanning tree mode, and you can see the PortFast is enabled by default, and BPDU Guard is also enabled right there. All these are the ones: BPDU filter, loop guard, uplink fast, backbone fast. These ones you'll find at CCNP level. They are beyond the scope of this course. Okay. Now I want to give you some assignments to be able to go and practice by yourself. It can look very easy when I'm doing, but not when you are doing them. And so for your practice, number one here, please do watch a video on 10.5.6. Do watch a video on 10.5.6. That is the first assignment, is video watching. The second assignment is 11.1.9, 11.1.9, and 11.1.10. 11.1.9 and 11.1.10. All right. The next assignment is 11.2.3. 11.2.3. 11.2.3. My next assignment is 11.3.5. 11.3.5 for your practice. Then 11.4.4. 11.4.4. Then 11.5.4. Then 11.5.4. And my last assignment for you guys, which is going to combine all of them. My last assignment is combining everything that we have learned today, is 1161. 1161. A very interesting activity. It actually, basically looks like this. It combines everything that we have learned today. And, it has all these, layer 3 switch here with 2 layer 2 switches. And there's so much to be configured here. You're going to create secure trunks. You're going to secure and use switch ports, implement port security, DHCP snooping, and you're going to configure rapid per VSD PortFast and BPDU Guard here. And so from what I can see here, you're going to do a lot of activities here that is good for your learning, all right? And so please do practice. This is 1161, very important for your learning. And when you get to do that, I think, that is going to be something nice for you to learn. Otherwise, I think that marks the end of this chapter. And I mean, for this particular part here, and definitely I'll see you next in the